Yep.
Amazing. So we are going to look at our code base. First of all, I am just deleting all the cache and VS Code thing that gets initiated when we deploy our contracts. So let me just mm, delete this cache as well, and then we will go through the code base. Or let me just do one more thing. Firstly, let me close the session and open it again. So what we will do, we will use terminal to open this, and we are having the WSL installed. So for even if you are on Windows, it is recommended to use the Ubuntu. So what you can do to install the Linux environment, you can search for WSL, and WSL2 is the recommended one that is being used generally. So what you can do is you can install it uh, from here, I guess. Just give me a second. I'll WSL2 install, and you will find the link over here. Install Linux on Windows, and you can follow the guidelines, and you can install it. You'll need to have the PowerShell installed. Window comes with the PowerShell, and you can install uh, with the WSL install. WSL is hyphen hyphen shell. If I'm correct, it's hyphen. I'm not sure about this. What we used to call these ones. So you can install WSL within your system, and then you can get started with the Linux environment. And then what you can do is uh, you'll need to cd and go to the file, and some shortcuts are like ls is there. Oh, sorry, just give me a second. I have cd and then ls. That doesn't make any sense. So ls, you can find all the directories that are there. With the l, you can find all the directories with the slash. And if you want to have all the list, then you can have it to be as uh, else. This I just search it, what we call this symbol. Actually, I'm not sure about this symbol. Shiv, are you sure about this symbol? What we call, I guess hyphen is, it is called as hyphen, because I need to use this a lot. So I just want to be sure what we used to call this symbol. Shiv, are
Yeah,
you
you can call it. Yep. You can also call this that way.
there? Mhm.
Yeah.
Okay. I guess I'll just search it one more time. That would be much better. Hyphen symbol. Yep. Hyphen is, we call it as hyphen. So, yep. So hyphen is there. Then L hyphen A, and then we can find the directory, the directories and the files here. And then what we can do is we can now visit our code base, that is cd desktop. Then we are having it to be in the, I guess it's in the saves, and I guess it's in the hard hat saves. And okay, what I'll do is ls cd saves and ls. Okay, I guess I have missed that one. So what I'll do is I'll just open it from the code itself. I forgot the path. So you can also use this shortcuts to open the VS Code, or even with the terminal, you can use this command to open the code, Visual Studio Code, code dot. Whenever you will put this dot, that means the current directory that you want to be in. If I go in the desktop folder, let's say I'm in the desktop and I want to open the VS Code on the desktop, then what I'll do is I'll click code dot, and it will open the desktop, the VS Code on the desktop side. So that's how the things are. And now what we can do is we can look on our code base. So first of all, we are having some mm, it this project is deployed on the hard hat for the Solidity development environment. Here is hard hat. So you can find all, what you can do is you can first yarn in it, and then you can install, you first need to add the hard hat within your system, within your file, and then you can create a folder, create a file for the contracts, and this will what you will find is contracts deploy contract file will be there. Then you will be having the node modules within that, and hardware config ts file will be there, and the package.json file with these last four files will be there, except sol.json, that is v0.8.16, that is the Solidity version that we are using. Other than that, what we are using is .env file to store our environment variables. Other than that, we are having the gets reporter, hard gets reporter, and hard ether scan to verify our contracts on the ether scan. Other than that, we are having the hard hat upgrades so as to have the upgradable contracts. Then Solidity coverage to know how much contracts we have written the test for, and then we are having the hard hat deploy. It is a kind of a wrapper on top of hard hat so as to provide uh, to offer better deployment services. So what we will be having is we can create a deploy folder, and within that we can have a custom functions that is await deployments, and then we can call on and deploy the contracts on the chain, on the blockchain. So let's get started with this first of all. So what we are having is core contract, and within that we are having the buy sell contract, and in that we are having uh, let me just check where that is missing. I guess I have deleted that one by mistake while I was deleting that. I guess I have deleted that contract as well. Yes, by Solidity open file, and I guess I'll need to discard the changes. Yes, yep, by mistake I have did this thing. Yes, so what we are doing is, first of all, we are specifying the identifier, the license identifier, that is busl 1.1. In this case, whenever someone wants to use our code, then they will need to notify us. Then we are having the pragma Solidity, and that is the version of the Solidity compiler that we are using. Then after which, this is a net spec. We will go into detail about the net specs here. And for net specs, what you can do is you can visit, always refer soliditylang.org, the documents of the documentation of the Solidity. Whenever you get it stuck anywhere, this is one of the best resources you can have with yourself, and you can find all the things here, like at the rate title, what is the contract title, what this contract is for, and then you can have the author name, then you can have the notice. You can use this contract for only the most basic simulation, that is you are notifying the user as well as the dev, those who are reading your contract actually can know what this contract is for. And then you can have custom experimental. These are the uh, custom net specs that you specify, the documentation that you specify within that. Other than that, if now let's go deeper in this one. So then we are importing. I guess there is some mistake over here. Let me just first correct it up, because it should not give us an error. Override, okay. Override again. What I'll do is I'll just delete it for now. I guess I have done something wrong while I was sharing the screen. I have deleted it within few seconds, and that's how something goes wrong. Yes, I'll need to change this file, but for now we will go through the things. That is, first of all, we are importing the interfaces, and while importing the interfaces, we are importing first of all I buy sell contract. Yesterday we have talked about the interfaces in a bit. So what we will do is we will visit I buy sell SZT. So I have already said you that here we just define the function without its implementation. We just define the function without its implementation. Other than that, what we can do in the interfaces, we can define the custom errors here. And generally, while defining the errors, we generally first of all use the contract name, and then we provided these two uh, underscore, and then we define the kind of the error that the user should be notified, the custom error the user should be notified. And then we can also include the events within the interfaces itself. And then other than that, what we can do is we'll need to define the functions. And whenever we define the function, they are needed to be external. They can't be public or internal while defining it in the interfaces. And that's how you can restrict the contract that is inheriting it to use these function within their code base. So if I want to change anything within this contract, then it would give me an error itself. So here I guess there are a number of things that have reverted while I changed this code. So this is going to be a good tutorial. So what we can do is we can learn a lot this time, I guess. So number of other things are there, like contracts upgradable is there. So with contracts upgradable contracts are those contract which we have, I guess we have covered that yesterday in the last 2 minutes of our session. So uh, in the upgradable contracts, what we can achieve is whenever there is an upgradable contract, you can change the implementation of the contract. Let's say you are having this implementation, the functions written over here, then you might define a new function, or you can override these function while maintaining the state variables. Where are the state variables? These variable are the state variables. You can maintain the values in these state variables as well as on these, uh, if there are. Okay, let me just open. I guess we will be having in the constant flow, I guess. So if you are having something like uh, structs are there, so these are the state variables that are stored on the uh, that are stored, and whenever something changes on the blockchain, so you want to ensure that these values remain intact. Means, let's say you have deployed a contract and you want to you have done some, let's say you have issued 10 tokens to someone, to a person, b person, c person, and let's say 1,000 persons. And whenever you are upgrading a contract, you are just deploying a new contract in itself. So what will happen is you will need to have more functions inbuilt so as to provide those tokens to them. You will need to have a record of, firstly you will need to have the record that you have uh, given uh, such many tokens to such many individuals. First you will need to collect those data, and then you can transfer those tokens to the persons. So the other way is, first of all, the ensure that the state variables are stored without means uh, getting them, means you are not changing any state variable. You are having the data of those, but you are just modifying the functions. So there are generally three kind of upgradable contracts. Means you can upgrade the contracts in the three way. That is, first of all, the transparent proxy, then we can have UPS proxy, and then the diamond facet proxy. These are the three ones. So we have already gone in detail about these. This is one of the error that we are getting, that is we can mark it as an abstract. So there are two or three kind of things. First, we can have a contract, then we can have an abstract contract in which we can specify some of the functions of the contract that we inherit from. Let's say we have inherited I by cell SAT contract interface, and we are just, let's say, implementing two or three functions out of 100 functions from the I by cell SAT. Then in that case, we will be marking it as an abstract. Or if we are changing something, let's say what is happening over here is, if you'll see, I am having deadline VRNS, and most probably I am getting the error because I before means pushing the code on the GitHub, I actually forgot to like have these things updated. So what I'll need to do is, first of all, I'll need to change these data, and then you can find these error to be removed from here. And I guess same will be with the same will be with by SCT. So what I'll need to do is I'll need to visit biasity, and that is okay, I guess. Yes, there is some error also. Actually, I have tried to use the address of the user address. That's how, and that's how the restrictions works actually. So you are having an interface, you are restricting the function to use the same kind of data that is there you have defined within the within the interfaces, and your contract needs to implement the very same kind of data. And now what we are having is number of errors that we are now having. So I'll need to do is I'll need to change it to value, and that will remove some of the errors, and only one error is left. And here what we are having, the error is related to this, because we are not having any memory now, so we can't have these things. it, because we earlier were calling the data from the array, and now we are calling the data from the uint. So that's how the things can be fixed. Now let's coming upon the later these sections. So first of all, we are defining all these things. We are specifying the documentation for the variables that we have specified, the state variables. So you can find these to be as a private immutable, and for the immutable state variables, what we'll need to do is we'll need to have them included within the constructor, and they can't be called within any of the functions. So what I'll do, first of all, you can use control and what we call this as uh, let me just, so if all this function actually, this is a, if you will use this control plus this symbol, then what you can do is you can close the terminal. So if you will click this, the terminal will be closed, and the same goes to open the terminal. So these are the shortcuts that I'll also try to include within this workshop, so that you can write the contract in a much more faster manner. And now let's get back on the tutorial. So we have defined u into 56, and this is a private variable, means the value that is there will be will not be having any getter function. So whenever there is a public function, we used to have a getter function. So if you have deployed the contract, you will not need to create any getter function for this. By default, if it was a public function, then a getter function would have been created. But as it is a private function, no one can see the value of this without we creating a getter function for these ones. Then we are having the constant values. These are defined one time. You can't change the value of these ones, and you can't define in the later stages of the contract. If I'll try to call these, let's say if I'm calling this to be as here as 9, it would raise an error, because we can't do so, because it has already been defined as a constant, so it is not allowed. Now let's go on the later stages. Then we are defining some of the other, we are calling the other contracts using our contracts. So what we are doing is we are uh, specifying the contract. Here what we are doing is, let's say for the I coverage pool, let's say, or IRC20, I want to call, let's say I want to transfer die from one user to another user via our contract. So what we need to do is we will need to specify the IRC20 where all the functions are implemented. So what I interfaces do is, if I'll go in the interfaces itself, so IRC20 is there. So what it does is, let me just open IRC20 as well. So what it does is it includes all the functions that are present within the contract. So it is just a schema of that. What you can say is like a blueprint to be kind of. So all the functions is specified here can be called using this contract, because what we are doing is now we are inheriting this contract. We are using this contract, and we are specifying the address. We are, first of all, this is a token GSDT. We are, what we are doing here is we are specifying that there is a token GSDT, and then in the later stage when we are calling it in the function, we are defining the address that you will find this IRC20 standard, IRC20 contract to be there in this address. This is the here you can enter via the parameters entered. You can pass in the value, and this code this will be initialized, and then you can call all the functions that are present over here. So you can either call balance of, total supply, transfer, allowance, or any of the function that is needed. So that's how you can interact with the other contracts or uh, other things that are deployed on the blockchain. Now let's coming up on the other things. These are for the security purposes. We generally used to define pause and unpause so as to restrict the user to interacting with our contract if we found some bugs, or if there is a vulnerability, or if hack has happened, and we just want to restrict the user from using our contract or functions in a sense. So what we do is, we first of all, we can either create our own contract, or we can call the open zeppelin contract, and we can inherit. um, what we are doing is, here is we are inheriting the contract from this possible upgradable contract. So what it does is, it provides us a kind of a it provides us the functions, and whenever we initialize those functions, whenever we initialize this possible init, in this case we are using the upgradable contract, so that's why we are not having any constructor in the upgradable contracts. We do not have the constructor, and there is a reason for that, but I'll discuss it on the later stages. But because these are kind of the upgradable contracts, we are having the functions, then we initialize those contract within our this function. If I'll go here, so within the init function we are initializing this in the initialize function, where it is where is the initialize. So we are initializing the base upgradable possible init function contract. So base upgradable possible contract is in itself is importing four contracts, that is the initializable, possible upgradable, then access control upgradable, and the reentrancy. Reentrancy is one of the major security threat, and also because of this, in the year, if I'm correct, in the year 2017 or 18, a DAO lost lost value in around, I guess, in the millions of dollars, because this reentrancy was present within the contract code. So this is uh, one of the kind of a bug, or kind of a, not to be as a bug, to be more precise, as to be as a vulnerability that the developer has created within the contract, uh, and the the exploiter exploited this vulnerability within the contract. So let's get more in depth. I guess we have covered pose and unpose, and now we can focus on this BySDT. So what we are doing here is, we are calling the BySDT token, and what it does is, it first of all takes these parameters, that is the user address, then value, then deadline. What we are using these parameters, it is taking the address of the user, and also what we'll need to do is, we'll need to create some other parameters. Uh, Actually, this time we can showcase what we have to write. In this case, what we are doing is, we are creating a modifier. Let's say we want to restrict the user uh, to use only a contract. If they are called from other contract, then only this permission will be allowed, otherwise it will not be allowed. So what we will do is, we'll check if the user, here what we are using is, we are using message of sender instead of message dot sender, because message of sender allow us to use for the meta transaction. If meta transaction is there, then message of sender is used. So require message of sender equals what, equals to be as coverage pool address. So what we can do is, we can specify the address of the coverage pool. Coverage pool here is a contract, and we are specifying it to first check and then only allow the function to be called. So what we will do is, we will call is permitted over here, and then what we will do is, we will specify it over here, is permitted, and That's it. So we are restricting. Also, what you can notice is we are having the multiple constructor here. Sorry, modifier. So is permitted is there, as well as if not post modifier is there. Both the modifiers can means you can have as many as modifiers you want to have within a function, and then what will happen is according to the modifier or modifier code, that is if this underscore and then this column is there column, then first of all this condition will be checked, and then only the function will work. If this condition, if this thing is written on the top, then first of all the function will be executed, and then only this condition will be checked. So in most of the cases, or in general cases, we generally used to have we generally want to have the checks at the top, means before calling the function, and then we want to proceed with the functions. So now we are also checking for the reentrancy. If there is a reentrancy, we just want to avoid, and for that we are using the reentrancy guard. So we have already talked about the reentrancy thing and how it affected the DAO. And even if someone want to go in detail, what they can do is reentrancy hack, reentrancy DAO hack, and they can find all the details over here. The DAO hack that has happened in the past, and they can find all the details. See, here it is. On June 7, 2016, the DAO was hacked and 3.6 million ether, that is over $50 million were stolen from the very first reentrancy attack. And after that, there are a number of, or I say a bunch of attacks that have happened. The reentrancy attack that have happened on these smart contracts of the organizations, or to be more precise, the projects. And then we are just returning bool. And in this case, what we are checking, first of all, we are checking if the token counter is if the token counter is less than 118, then if token counter is less than 118 and value is less than 118, then we want to revert the revert. 118 is what? It is 1 raised to 10 raised to the power 18. So what we can do is, this is the value for 118. Then we are just verifying if the value, and also you can also see here is it is the value defined, and in the generally in the token the value is like the decimals are generally 18 decimals. So what we can do is we can also look in the token contract. Most token contracts have it to be as 18 decimals, and some tokens like if you are having the I guess USDC, they are having the 6 decimal positions, because solidity by itself do not allow us to have the decimals. So what we do is we, if we are having let's say if we want to transfer $1, what I'll do is I'll just have it. If we want to transfer $1, or if I am having $1, it will be represented in most of the tokens as 1 into 118, that is equal to 10 raised to the power 18. So as we can overcome the overcome this security thing that is not allowing the decimal, because for a reason solidity does not allow it, because by the nature of the solidity, contracts are deterministic. If I am having, let's say I am allowing the uh, decimal value, then whosoever is like verifying the contract, they can't have the right answer, because the precision will be different on the different machines. That's why they do not allow any kind of like decimal values within those contracts. So I guess I do have cleared this doubt as well. And with this, they do specify this to be as 118 generally. And if you can also find which precision are they using by going to the ERC20 upgradable ERC20 contract, whichever they are inheriting, and then you can call this function that is decimal, and it will return you the value with what they are utilizing. Means if they are having the 18 decimals, then the value will be like 118 for $1, and if they are having it to be as let's say if the dot decimals return 6, then $1 will be represented as 1 is 6 over there, and so on. Now I guess control Z would be much better here. Just undo the things here, and yes, I guess I have covered this one. Then let me just also undo the things over here. Yep. So we have checked this condition, then we are calling another function within our contract. This is an external contract, external function, and then what we are calling this function, the calculate SZT function, you can find it to be as a public, means this function can be called by anyone. If generally if you are if you are not calling anything, let's say you are not either uh, having you are just having the you are not updating any state variable, or you are not calling another contract, then you can surely go for the public. It is one of the most open kind of modifier, access modifier, that allows you to that allow anyone can access this function. But generally we go in the order. First of all, we check if we can use the private function, then we check for the internal. If we want, if our function can just be an internal, then we move to the external, and lastly we go for the public. So it's the order actually. So first of all, we just want to make sure that if if our function can be just private, and if the things works, then we just want to have the private function at first. Then in the second order, we want to check if if we can't have the private function, then whether the internal function can be there. So if the internal function can be there, that is good. Otherwise we go for the external, and then the last comes the public. Then after calculating this, what we are doing is we are checking the balance of the user, that is message of sender. Instead of using, we can either use message of sender, message dot sender, or we can go with the message of sender. But the only difference is that if you are having the meta transactions are those transactions that are called by some other party. So in that case, what we will need to have is message.sender. Message of sender is allow us to call it via the call it during the meta transaction. You can also check the documentation over here, provides information about the current execution context, including the sender of the transaction and its data. While these are generally available via message.sender, that is over here, they should not be accessed in such a direct manner, since when dealing with the meta transaction, here you can find to be as meta transaction, the account is sending and paying for execution may not be the actual sender. Means the sender who is sending these who is paying and executing the contract might not be the actual sender. Means you are having some kind of a bot that is actually calling that function. In that case, you want to have message of sender to be there. So that's why we are using the message of sender. If someone calls using any other thing, then we can have the message of sender. Then we are just incrementing the value of the token counter, and then we are calling the permit function. So with the EIP 2612, I'll just show you EIP 2612. What you can have is, instead of having the token approval, you can have the signed approval. In this case, what it will do, it will generate a signature on the front end side for the user. They can call the function and they can generate a function, the permit function, and that permit function can be called. And when they will pass this values over here within this function permit, the owner will need to be specified, the expander will need to be specified, the value, deadline, v, r, and s, on which the user have put the value during the execution, during the front end execution. Means they would have provided the value, the expander, in the front end, and that's how the things can be like going from the approval, that is a gas, and that takes gas, to a gasless transaction. So means if you are having an approval function, if you are having the let's say you are having a token and you want to approve. First of all, if you are having a token and you want to transfer it to someone, first of all let us understand that you are having, let's say you are having 10 die, and you want to send it to, let's say, Shiv, then what you'll need to have, is you will need to first approve that I am the one who is willing to pay to Shiv these amount of token. So first of all, you will need to approve, and that is a gas transaction. So means you are going to pay some kind of value to the Ethereum, to the Ethereum miners who are mining those transactions. And first of all that, and if you are using the permit, then that can be avoided, because on the front end you are just creating a signature, and that signature's value, that is VRS, and the deadline is something that is different. VRS is the part of the signature that you are providing, and with that you can create a gasless transaction to be a, without calling to be an approved function. You just call a permit transaction, and then you pass it in with the deposit function, or let's say transfer function, and then you can avoid that cost. At the same time, what most of the protocols, including the Uniswap and many other protocols, what they used to do is they take unlimited approval at the very first time from the user. So what kind of vulnerability it produces is that, let's say, Uniswap or any other protocol have some kind of a bug within their contract. So what will happen is the user that is that have called the contract earlier have already gave the token approval to the Uniswap, and the hacker or the exploiter now can call and redeem all the tokens from that contract. So that is something that we need to take care. So with the permit function, we can actually avoid such kind of scenarios. So that is number one thing. And now we are here. Here, this is interesting. So what we will do is we will also actually write some code over here. So what we are here doing is we are actually, uh, let me just first of all token transfer die, and what I'll do is I'll first change it. I'll need to actually, we will actually be deleting this code, and we will actually make it better. So what we are doing is we are calling the transfer from function in the ERC20. So let's go in the ERC20 contract actually to show you something that is important to note for the security purposes. So in the IERC20, this transfer function actually returns a bool, and it actually does not check, it actually does not revert back if the transaction has been failed. Let's say you are transferring $100 to someone. Let's say you are a person A and you are transferring to person B, and let's say the transaction got failed, the transfer function has failed, but because you were not checking the value of the bool, what will happen is the function will not revert. It will just give a false value, and you haven't checked, and you have just called the function, and you have thought that the function, you have transferred the amount to that person, and now instant you have transferred the amount, now you are having that amount with you. So that is an issue. And if they are in the function, if they are there in the contract and you are not checking, then what will happen is, in this case, if I was not checking this function, then if I wasn't checking the condition of this function, whether the token has been transferred from the user to me, then what will happen is I will issue the SAT token to him while I wasn't even receiving the DAI token from him. So in this case, what we are doing here is we are taking the DAI tokens from the user, and we are issuing SAT token to the user, the saves and tokens to the user. That is a non-speculative token. So first of all, we want to check this condition. The other thing that we can do is, instead of checking this condition, what we can do is we can use the safe ERC20 contract. So what we can do is I'll just over to, I guess, constant flow agreement, I guess I have to have used, and the claim act, yes. So what I'll do is I'll use the safe ERC20 library. This is a library actually. So what we will do is we yesterday haven't gone through the library contracts. So what we will do is we will here import the library, and we'll write some code here itself. So in the library, if you will see, you are already having this IERC20 permittable contract. So what I will do is I do not want to import it again once again. So what I'll do is I'll just simply means delete that line. And in this library, what we will find is this is kind of a wrapper the on top of that IRC20 upgradable, that is IRC20 library contract interface. Sorry, IRC20 upgradable is a interface, and we are having the library on top of that, so as to provide a kind of a wrapper, a security wrapper. So this ensures that whatever function we call internally are secured. So these all these functions here you can find these. This is a low level code. This is encode with selector. What it is doing is it is calling the transfer function. Dot selector is means in the encode dot ABI dot encode with selector. What we do is we specify the token, then we specify the function of the token, and then we uh, specify it to be as a selector. Means what it is doing is, if I'll go here IRC20 upgradable contract, uh, if I'll go in the IRC20 upgradable contract, here you can find it to be as a transfer function. So what I am doing here is I am calling token.transfer, and I am selecting that transfer function, and I am calling this function. I am calling this function and I am passing on both the values, that is to and amount. So I am passing over these values and I am checking if there is any call optional return. If there is something that needs to, if the call gets reverted, then it will give us an error. So it is an internal function that is kind of a wrapper on top of IRC20. So we will be using this one for our contracts as well. So what we will do is, how we want to use this, how we generally use these things are, as we will first use safe ERC20 for what we will use it. We will be using it for uh, IRC20 extended, as well as for uh, what I'll do is, you can also use Control C, Control V, that will copy the lines. And what I can do is I will use it for IRC20 upgradable as well, and then I'll use it for IRC20 permit upgradable as well. So it will do all the tasks for us, heavy lifting for us. And then what we can do is we can have these functions to be changed. So what I'll do is I'll press Control and F2, Control plus F2, and I want to ensure that match case is checked, and as well as match all word is checked. So as only this function will be changed, this function. So what I'll do is, wherever this function will be, this value will be changed. You can see here this value has been changed, here it has been changed. And if I'll call this function, now it is secured. And why it is giving us an error now? Because there is no return function. So what we will need to do is, we'll just need to remove this thing over from here and from here as well. And we also need to delete this transfer die from here as well, and this will work well. And same goes here. Most probably, yes, I am checking the contract. So that's how you can improvise on the code, as well as you can have the safe permit. So what I'll do is, again I'll press Control plus F2, and I'll change the code to be as from permit to safe permit, so as to have a kind of a security layer on top of the initial function. So this is how we do it. And then what I'll need to do is, I guess now let's jump back on the contract where we were. So just one more changes that we have to do is, we'll change it to safe transfer. You can also check one more thing from the contract. Let me just show you once I finish this one. You can also check over here what they are doing. Safe transfer is calling the transfer function. If I'll go for the safe transfer from, it is calling the transfer from function, and same goes for everyone. They are just calling the very same function with just safe. So what they are ensuring, if the transaction gets interrupted or gets reverted, then they will give us an error by reverting the transaction. And we just not need to rely on the bool, means on the bool variable that gets returned, because most of the time the developer who are writing the contracts actually forget to check the conditions. So this is a very important case. So what we will do is, instead of having this bool, what I'll do is, here I'll just control X and I'll delete this line. Just, I do know the contract, that's why I'm doing this kind of a shit. But first of all, you need to read the you need to see what you are doing whenever you are doing such kind of a thing. Like, I'm just playing around this code right now, and you should avoid actually, like how I am playing right now. So it has been fixed for now. Means the contract is good, not just a temporary fix, just to let you know. So what we are calling again now, we have already gone through the public function. Now we will go through the private function. So for the private function, it is generally recommended to use the underscore with the, whenever we are writing any private function. So this is the function name, that is the mint gsdt, and we are specifying the underscore. That means it is a private function. A private or an internal function means only the smart contracts can call these function, and the other contracts means the other user cannot call it, other than the contracts. So we are calling the main function, and this ensures, this checks some kind of a things like the balance of the user, how much SAT token the user have. Then it calls on the coverage pool to check how much token the user has underwrite before. So these are some of the condition that it check, and if the condition gets true, then only it emits a event. So we have already discussed it. uh, so what I'll do is, I'll go in the I by SLSCT, so as to show you what actually happens, what are the events actually. So here you can see there are some events listed over here. So what these events are kind of a thing that the whenever you are on a, let's say you are having a front end, a React application, or some kind of an application with the event, you can listen for the call. Let's say uh, you have performed a transaction, you have called a function on called a function, and that has been now uh, there in the this mempool. Mempool is one of the thing that you should know. Mempools are kind of a place where all the pending transactions generally lay. Means before they get into the blocks, they are stored in the mempool. So you can also uh, the best thing about Google is that you can check anything. So just search mempool and you can find all the things about this. It is just like all the transaction before reaching to the block gets there within the mempool, and then the miners who are mining those transactions onto the blocks select the transactions whichever they want from the mempool, and then they like execute they like verify those transaction and then put it on the blocks. So I guess I'm clear with that, and then what I can do is, I'll go in more detail about these other things. uh, Safe permit I have already talked about. Then that is a burn from function. What it does is, if it's just a function, if you are having a ERC20 token and if you want to burn some kind of token from the user, what it this function generally does is, it whatever token you have, it assign it to the address 0, so that no one can receive those tokens. You are just burning those tokens from your end. So I guess I have cleared this one. And then we are having the view as it is, that this is just a view function. And something that also we can check is, uh, see here, if you are having these contracts written these functions written over here, so what you can do is, instead of just let's say you are having this function, you are using those function within these contracts. So what you can do is, you can override these things. So you are specifying that I am overriding some things from I am means uh, inheriting this I by cell SZT, and I am modifying the changes. I'm making some changes within this function that has been written over at the interface. So this is something that we generally used to do. We do, and this is a public function. Most of the view functions are either external or public. They are generally not like internal or private function, generally speaking. And then these are just private functions, and I guess I do have covered this one. uh, Still we are having some 10 minutes, so what I'll do is I'll try to explain few more things about this contract. I guess there I if I can find something that is much more interesting. So here we are having an instruct. Instruct can't be a long, like you can't have more than, I guess, 10, means I guess 12 to 15, and then it will give us the stack error, because at the end of the day it the block these data are stored in the stack. So you can't have a very long struct. So what you'll need to do, in case if you ever get stuck with uh, that kind of error, what I can do is I can just show to you. If I'll just compile it for now, let me just control and then that function that I had, this one, and this will open us the terminal. And what I can do is now, if I'll call yarn hardhead compile, it will compile everything. It will not be having any error, I guess. If it will be having any errors, yes, it is just warnings. So never mind for these two warnings. I guess I do have missed something. Yes, in the buy sell contract there is something that I'll need to change. That's why these warnings are there. Otherwise the 73 files have already been compiled. What now, to just showcase you what will happen if I'll increase this. Let's say I am entering you into 56a, and let's say control B and C, and for now it let it to be as AB for now, just for the testing purpose. And what I'll do is I'll create one more so as to make sure that we can see the error itself. So it will now give us an error, and what it gives an error is stack too deep, because uh, at the end of the day, as I have already mentioned, these uh, whenever we are compiling any contract, these is stored in the stack. And if the means the data goes beyond the stack, then it's gonna give us an error. And how can we avoid it? We can use the mapping in that case, so as to avoid that kind of a thing. And what I'll do is I'll click on the terminal, and then I'll press the same command that I had earlier, and then it will close that thing. So what I'll do is I'll control Z so as to make sure I haven't changed anything. So that will ensure. Okay, and then we are just having the initializer function. And yes, uh, since I am having 8 minutes for now, uh, what I'll do is I'll show you one more thing, that is a slither. Slither is a static analyzer tool that is used for the audits, security audits, so as to make sure your contract is bug free and are not having any kind of error. So high vulnerability are shown in the high one, then in the medium kind of a vulnerability, and then in the low you will find the low vulnerability. So here also, since it is a static analyzer, you will find something that actually might not be a bug within your contract, or might not be a kind of a issue within your contract, and it will still give you an error. Like, let's say you can see here, it is, you are having some kind of an it is giving you a warning here. You are performing a multiplication on the result of a division, but we actually want to do it. That's why we just ignore this kind of a error warning, and we will just go with what we just are making ensure that this is something that we haven't missed by ourselves. So being a static analyzer, it gives you every possible kind of a warning, and it doesn't actually like check number of things. If I'll just for the testing purposes, I also have brought something that actually show you what could go, means it can actually give us a kind of a what we can say, false kind of a warnings. So in this case, what we are doing is we are using the uups proxy over here. uups proxy is there. So what I'll do is I'll just uncomment this code, and then I'll come uncomment this code as well. Yes. Yes, it has been uncommented. What I'll need to do is I'll need to make sure this is enclosed, because I'm already having the pragma solidity over here. And if you will see, it is a uups upgradable. As I had already told you, you can either have the uups upgradability, or you can have the transparency upgradability, or you can have either have the diamond. So here we are just using the uups, and we are initializing the function, and we are having the authorize upgrade function. So once I'll save it, and if I'll again call this, this is a token. So what I'll do is, first of all, I'll delete. You will find it to be there. There will be one warning in the high, but it would be a actually, to be real, it would be a false warning, because initialize function will only be called once 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 you are deploying the contract. So here you can find, here it is giving us an warning that is box is an upgradable contract that does not protect its initialize function, this initialize function. But since it is having an initializer, what it does is it makes ensure that whenever we are deploying the contract, this function will be called automatically. And when we are calling this contract, then only the onable function will be initialized, and that makes sure that the upgradable functions are can only be called by the owner itself. So it is a false warning over here. So you can sometimes find the false warning over within the slither. And what you can do is, how to install the slither is very pretty simple. You can go into the extensions tab, and you can install the slither within your within your uh, PC or computer, sorry, laptop, whichever you are having, and then you can just install it, and you can run uh, run by this command, and you can refresh after you have make any changes. Then you can just refresh it, and if you are sure that if you just want to make sure that the screens are clear, like let's say you do not want to have these kind of underlines, then what you can do is you can just click on the delete function, delete button, and it will just delete everything from this. What I'll do is, for now, I'll just comment this out, and what I'll make sure is this thing is open, and this thing is also open. Otherwise, it will show us the warning 0.8.16 in this case. And I'll just even actually control Z, if we even are having this kind of a thing, because it is having a caret, that means any kind of a compiler that is above 0.8.2, that includes 0.8.16, is allowed. So it will not give us any kind of an error. But in case if I just change it to 0.8.17, in this case it will give us an error, because we are now saying the compiler that we are allowing you to have 0.8.17 or above kind of a compiler, and Solidity file to have the compiler uh, above 0.8.17 or 0.8.17. So what I'll do is I'll change it to 0.8.16, and it will again work. Or we can even remove the caret, so as to make sure that we are just deploying the contract only using this. It is generally recommended to, for the security purposes, to specify the compiler version and not use the caret. And also you can actually check some of the things over here. I'll uh, I guess I can't share the link in the YouTube, I guess. So what you can do is you can visit this GitHub page that actually notifies you about all the possible kind of error that your contract might have, that actually this slither actually checks for the static analyzer. And also you can read more about these things. Let's say it also describes you about the exploit scenarios. What are the exploit scenarios that are possible if you write the contract in such kind of a way. Let's Here it actually describes you how you can actually your contract can get exploited. And this is one of the most interesting thing that you can read actually. So this is one of the thing that you should actually go for. And this documentation is always like, you should always read documentation. Nothing is better than documentation ever, not even this tutorial, at any point in time. And also you can go for the Solidity by example.org. This is one of the most fantastic uh, what I can say to be as a tutorial page where you can find number of things that you can visit. And then these are the I guess one of the best resources that you can have. And then you do have the Google, and you can just even, if you find any kind of a issue or trouble reading any kind of a contract, or you while writing a contract, you can just ping me up on Twitter. uh, Here is my Twitter. Just a second, don't check. 1998, and you can just ping me up, and I'll be more than happy to help you out. I guess I do have covered a lot. I guess, Shiv, over to you. Thanks a lot, everyone, for patiently listening to me. Thanks a lot.
Thank you, Anju. Thank you for taking these 3 days of session continuously. Even yesterday, you had taken a long session of 2 hours. Thank you very much.
Thank you.
Also, guys, if you have any doubts, you can ask in the Discord section. We also created a separate page for Solidity. If you have any doubts, do ask there. Anshik will be will be solving your doubts there.
Yeah, of
Thank you,
course.
Anshik.
Yeah. Thanks a lot. Have a great day, everyone. Bye bye. See ya.